Problem number 22. Find the length of the curve. R of t is t squared minus 1, 3t squared minus 2, t squared plus 1. T is running from 1 to 2. How do we find arc length? How do we find arc length? We integrate from 1 to 2 the magnitude of the derivative of r of t. And we're thinking of this as motion, we're integrating the speed here. So first we need r prime of t. R prime of t is going to be 2t, 6t, 2t. To find the speed here is the square root of 2t squared plus 6t squared plus 2t squared. And this is the square root. Simplify this as the square root of 44t squared. The square root of 44t squared can be simplified to 2 square root 11 times t. Note here the square root of t squared is just t because t here is positive. T is running between 1 and 2. So really, what is the thing we're integrating? From 1 to 2 of 2 times square root 11 times t. And so the antiderivative of this, so square root 11 times t squared, plug in 1 to 2. And so this would be square root of 11 times 2 squared minus 1 squared. So 3 times square root of 11. I also asked you to find a unit vector tangent to the curve when t is equal to 2. So what would that look like? So a vector that's tangent to the curve at t is equal to 2 is just r prime of 2. R prime of 2 up here, we see 4 and 12 and 4. To turn this into a unit vector, we need to divide by the length. The length of r prime of 2 is square root of 4 squared plus 12 squared plus 4 squared. This is going to be 144 plus 16 plus 16. So that's going to be 144 plus 32 is the square root of 176. So the unit vector tangent here is 1 over square root of 176. I think you can simplify that square root if you want to, but this is a perfectly fine final answer. Okay, so for that is problem number 22. Let's take a look at problem number 23. New problem number 23. A spring gun at ground level fires a golf ball at an angle of pi over 4 radians, and the ball lands 10 meters away. So the picture that we should have is this is what happens. This is what happens where this angle theta is pi over 2 radians and our golf ball lands 10 meters away. Now we should remember our formula for ideal projectile motion. And so that's going to be r of t is going to equal v naught cosine theta times t, all that times I hat, plus v naught sine alpha times t minus 1/2 gt squared times j hat. Here g is, we'll use the approximation, g is 9.8 meters per second squared because we're working in metric units with that meter there. Okay, so in this problem, we are given that theta is going to equal pi over 2. So cosine of pi over 2 and sine of pi over 2, those are both equal to 1 over square root 2. So our r of t is going to be v naught t over square root 2 I hat plus v naught t over square root 2 minus 1/2 gt squared times j hat. Now, this is giving, so the thing that's going on here is that we're given that the range is 10 meters. The range is 10 meters, and we need to figure out what was v naught, what was the initial speed. The thing that I'm going to do here is you can just quickly look in the textbook to see, or consult your notes to see what the formula is for the range. I'm going to just do all of the work to derive that for us here, the formula for the range. So the thing to think about for the range, what happens when the range right here, when the ball lands, when the golf ball lands, this is when the j hat component here is equal to 0. So we want to set this 0 equal to v naught t over square root 2 minus 1/2 gt squared. We want to set this equal to 0. If we rearrange, we get 1/2 gt squared is equal to v naught t over square root 2. And realize there's a factor on t of both sides. So this corresponds to one solution as t is equal to 0. T is equal to 0 is the solution that represents that the golf ball is starting at ground level when time is 0. So we can divide both sides. That's not the solution we're looking for, so we can divide both sides by t to get 1/2 gt is equal to v naught over square root 2. And we want to figure out what is the time. At what time does the ball land? And this is going to be t is equal to v naught, 2v naught over square root 2g, which is v naught times square root 2 over g. So this is the time at which the ball lands. Now we still don't know what v naught is, but what we're going to do is we're going to take the time at which the ball lands and substitute it into the I hat component. So the I hat component here, v naught divided by square root 2 times v naught square root 2 divided by g. This will simplify down to cancels cancel v naught squared over g, and we want this to equal 10 meters. We want this to equal 10 meters because we are told that the range here is 10 meters. At time t is equal to square root 2 v naught over g, the ball just landed and we want it to land 10 meters away. This will give us the equation for the x component, the I hat component, when it lands. So solving this for v naught in terms of g, v naught is equal to the square root of 10g. Using g is 9.8, it's equal to the square root of oops, there shouldn't be a period there, a decimal point there, and so this is like 7 times square root 2. That's our approximation for what the ball's initial speed is, meters per second. Okay, so that's part A of this problem. For part B, for the same initial speed, find the two firing angles that make this range 6 meters. So now our R of t is going to be v naught, we just worked out, was 7 square root 2 cosine t I hat plus 7 square root 2 sine theta t minus 1/2 gt squared j hat here. And now, oops, I left out cosine theta. Okay, now we have to leave in these, like the cosine theta and the sine theta here, because we do care about when, we are going to be changing this. It's not pi over, oh, by the way, silly Matthew, way back when I made a big boo-boo. Okay, this was supposed to be pi over 4 radians. My mind was on autopilot. My apologies for that. Okay, if that was concerning you, of course, if we were launching at a angle of pi over 2 radians, that's pointing straight up. The projectile just goes straight up and comes back down. Pretty boring. Okay, so this is our new projectile motion, and we want now the range to be 6 meters. And so at this point, I'm just going to go ahead and pull out the textbook and refer to the formula for the range. We could rederive it if we wanted to. I'm just going to say the range R is equal to V naught squared over G times sine of 2 theta. I've been using theta, books using alpha. It's clear what that means, the angle. So V naught squared divided by G, V naught squared divided by G, that was 10 back here. So this is going to be 10 times sine of 2 theta, and we want this to equal 6 meters. So 6 divided by 10 is equal to sine of 2 theta. And so there's going to be, this is what we can do here. We can just say theta is equal to, of course that's 3/5. Theta is equal to arc sine of 3/5, all of that divided by 2. And this is one angle, and then the other angle that this will work for is going to be, should be theta is equal to pi minus arc sine of 3/5, all of that divided by, all of that divided by 2.